steel industry is notorious for its unchanging manner and consistent performance. After all, steel runs on carbon-emitting blast furnaces. These hungry furnaces are meant to remain in continuous operation for over a decade on average. So how could the steel industry prepare to meet recent decarbonization and emission goals in the US? With the help of upcoming engineers and advancements in the steelmaking processes, this great steel pivot may be possible. Steel, one of the most iconic materials in modern society, and an industry worth a little over $927 billion, has faced historically high barriers in lowering carbon emissions. In 2018, the industry contributed to approximately 8% of all global emissions. This is because the primary process in steelmaking is chemically dependent on carbon to reduce the ore into steel. Steel is reduced in blast furnaces with carbon monoxide and solid carbon. And while it is possible to use other gases to reduce this ore, it is both chemically and economically difficult. The steel is also mixed with pre- and post-consumer steel scrap, steel either left over from the manufacturing process or used by consumers, respectively. These processes are highly energy intensive as the energy is used to directly melt the 1.9 billion metric tons of steel created per year. With developments in recycling and refining, the reliance of steel on carbon is changing. Companies are increasingly investing in renewable energy sources such as solar to offset the large amount of energy required to produce steel. Along with that, low-carbon processes that reduce iron ore into steel are becoming more attractive. Many companies are looking into the use of molten oxide reduction to melt raw iron, which uses electricity to reduce ore without a reducing agent like solid carbon. There is also a push for a higher use of steel recycling from the scrap into lower-grade products, as well as research to refine the scrap into higher-grade steel. This is because for every ton of steel scrap used instead of iron ore, 1.5 tons of carbon dioxide emissions are avoided. Professional organizations can affect the attraction of the next generation of engineers to the steel and materials industry through social and structural factors. To address social factors, collaborations with influential figures on social media platforms like YouTube can be leveraged. Considering that 95% of high schoolers have used YouTube, it is a popular pick for outreach to the younger audience. To impact structural factors, supporting the high schools near R1 universities with steel or materials specialties is crucial. Funding interactive experiences and clubs for these schools provides tangible opportunities for early education, influencing the preferences of potential engineers. For instance, AIST-sponsored events in Greater Pittsburgh, Pennsylvania, or Jefferson County, Colorado, can foster interest in steel among students who may later pursue related studies in nearby R1 schools. So there you have it. The steel industry is on the heels of shifting to a more sustainable and renewable age. Companies and pro-materials organizations can shape this change, engaging future engineers for a greener steel future.